Hello, everybody, and welcome back. This is a relatively short lecture just to introduce some of the more complex types that are available in Python. So we're actually going to learn about 4 new types today, some of which we've seen a little bit before, but we'll obviously expand on that and learn a little bit more advanced stuff about these types. So let's get into it. So we're going to learn about strings, lists, tuples, and dictionaries. So first, let's talk about strings. So strings are actually just a sequence of characters. So in reality, the way that they're represented internally, at least starting in Python version 3 and later, they're represented using bytes. And really, strings in simpler programming languages like C are typically just represented as an array of bytes. They're just basically bytes one after the other, and each byte represents a single character. That only allows you to have ASCII characters. Python version 3.0 started allowing all of the other possible encodings. Internally in Python, they represent the strings using the UTF-8 encoding, which is an encoding of Unicode, which allows us to, as the name kind of implies, combine a bunch of different encodings together. Or in other words, have an encoding that kind of allows you to represent all of the languages. So ASCII only allows us to represent basically the English characters. There's an extension of ASCII that allows you to have the English characters and also the accented characters for German and Spanish and so on. And then there's also a variant of ASCII that has the Hebrew characters and so on. And then there are also some specialized encodings that are used, like shift-JIS, for example, is the encoding that's used for Japanese characters. Thankfully, finally, Unicode was developed, which allows us to encode all of these character sets together into a single representation. Now, the complexity is that internally, UTF-8 uses as the name kind of implies, 8 bits or 1 byte of data for some characters. And it might take even more characters. Like there's no limit to the number of characters it can take, but it might take 2 bytes or 3 bytes or 4 bytes to represent a character. And these are usually represented, ordered by excuse me, how common those characters are. So all of the ASCII characters are represented as small as possible. And then some relatively obscure characters like emojis and stuff are usually represented using 3 or 4 bytes. Okay, yeah, so you can, with Unicode, with the UTF-8 implementation specifically, allows you to have Hebrew characters, Arabic characters, simplified and traditional, Chinese, Japanese, and so on. All of those characters, and of course, all of your favorite emojis as well. Okay, so here in this example, we can see a traditional string, very similar to the ones that we've seen in the past. And basically what this is a way for us to type the characters. This is not a particularly interesting string because these are all ASCII characters. But internally, it's taking those ASCII characters and converting them into UTF-8. If you were to copy and paste non-ASCII characters into the string, Python will be just fine with it. You can copy in some Unicode characters, and there actually are ways that you can hold down the Alt key and type in Unicode characters if you know their Unicode ID. That's possible too. You can do that right directly inside some Python strings. Now internally, Python is representing it as actual bytes. If what you care about are the bytes, then what you can do is you can create a byte string with this little B prefix here. So these 2 strings obviously have the same exact characters inside, and internally they're going to use the same bytes. But if you use the name variable, it's going to try to present it in a human readable way. It's going to try to print out the actual characters themselves. But in the case of the B string, for some of the characters, in particular the ones that are multi-byte characters, it's going to represent those characters using their codes, their Unicode codes. So if I encode this way, then I'm expecting to use it in a context where I actually want the bytes that are represented, that string is represented by. That's useful if you want to save things to a binary file, or you want to send things across a network, or encrypt the data or compress the data, that kind of thing. You use binary for. Use bytes for. Okay. Most of the time, we're going to use this first version here. But obviously, later on, we'll get to input and output, and we'll be dealing with bytes a little later. So one of the interesting things that you can do with a string is you can use the square bracket operator to get the individual characters of a string. So square bracket means give me the thing at the index that I specify. So the square bracket down here with the 0 inside is I'm saying I want to get the character at index 0. So that's an important thing to get used to when it comes to Python programming. You have to remember that we start counting at 0. So the indexes always start at 0. So in this string, index 0 is this capital C here. Index 1 is the A. So this line of code right here is going to print out the capital C. So this name square bracket 0 is actually going to be a string value, a string that only contains one character, just the capital C. Okay, so that's one of the things that takes a little getting used to, is remembering to start indexing starting at 0. So if you say index 5, I don't mean the 5th character. So that would be 0, 1, 2, 3, 4, 5. That's the 6th character. Okay, so 5 is not the A. 5 is the space after the A here. You can also index negatively. So that's actually not possible in most programming languages. Most programming languages allow you to use a 0-based index with a positive number or 0 as the index. But Python also allows you to use a negative index. And this is kind of handy because the 0 and the positive indexes, they allow you to count starting from the left-hand side of the string, and the negative indexes allow you to start counting from the right-hand side of the string. So these characters, for example, would be at index 0, 1, 2, 3, and the character starting from the right-hand side would be at index -1, -2, -3, -4. Okay, so if you know that it's 4 characters from the end of the string, you can use a negative index to reference it. And if you know it's, say, 4 characters from the beginning of the string, then you can use a 0 or positive index in order to reference that value. So this is pretty handy, this flexibility. Again, negative indexing is something that doesn't exist in most programming language, but it does exist in Python. All right, we can also use the slice operator, which is pretty much the same, except that it has 2 values inside the square brackets, potentially. We use a colon to separate the 2 values. What it allows us to do is, it's a slice operator more generally, but when we use it with a string, it allows us to create a substring of the string. So we can pull individual characters, but not the whole string. We can grab just a part of the string with the slice operator. So down here, we've got the same string, Carlo Rodriguez, and here I say, I want to get the values from 3 to 6. So one of the most important things to remember, well, there's 2 important things to remember. One, I already said, the start index it's 0-based. Okay, so when I say 3 in this case, we're talking about 0, 1, 2, 3. So we're saying starting at the L. But the other thing to remember, and this is quite confusing to people new to Python, is to note that even though the start index is inclusive, the end index here, 6, is exclusive. And that's a little bit strange, but it will start to make sense a little bit later. And it is consistent throughout with Python. So the range function works in exactly the same way. We specify the start number, the end number. The start number is included, and the end number is not included. So anyway, it's at least consistent, but it does take a little bit of getting used to. So this name 3:6 here is actually going to grab the characters. So 0, 1, 2, 3. So the L gets included, that's index 3. The A gets included, that's index 4. The space gets included, that's index 5. And the R does not get included because that's index 6. 6 is exclusive, right? If we leave the start index out, it assumes that you mean a start index of 0. In other words, starting from the beginning of the string. So if we just say bracket :4, that's the same as saying brackets 0 :4. But in this case, it just means go from index 0 all the way up to, but not including, index 4. So 0, 1, 2, 3. So this right here, this square bracket :4, produces capital C-A-R-L. Not A, which is the character at index 4, because index 4 doesn't get included. All right. If you exclude the end index, then it assumes you want to go all the way and including the end of the string. So this is actually really convenient because going all the way to the end of the string would require you to say square bracket 5 : len of name, which is really kind of inconvenient. And so in this case, we can just say 5 : it says go from index 5 all the way to the end of the string, including the last character of the string. Okay, so index 5 is 0, 1, 2, 3, 4, 5. That's the space. So the space gets included, and all the remaining characters, even the Z at the end, get included in the substring. And slices are even more powerful because you can also have a step. So you can actually have 3 values if you have a step operator. So in this case, we've got the same string, Carlos Rodriguez, and then we've got name from index 2 inclusive to index 8 exclusive, taking a step size of 2. Okay, so this is a little bit confusing, so bear with me here. Let's walk through a couple of examples to see how this works. So starting at index 2, 0, 1, 2. So starting at the R, so we include the R. And then we go with step size 2. So we don't go to the L, we go up 1 to index 4. Okay, so 2 plus 2 gives us 4. So we do include the A, because that's not quite at 8 yet. And then we go up by 2 again. That gives us the capital R. That's index 6, so that gets included. And then we go up by 2 again, and we get to 8, but 8 doesn't get included. So we don't include this D. Okay, so it's literally just the R, the A, and the capital R. Let's do one more example where we have a step size of 3 in this case. So we start at index 1, which is the A, and then we go to the index of the next A, right? Because this goes to index 4, so 1 plus 3. So we got 1 to 4, and then we go to index 7. So that brings us to the O, nope, D. So that includes the D in that case. Is that right? Yeah, A. 1, 2, 3. No, sorry, it's the O. Okay, so that brings us to index 7. And then adding another 3 to index 7 brings us to 10, but we don't include 10. Okay, so that's it. Just the A, and O. So this takes a little bit of practicing, especially remembering that the end index is exclusive and the beginning index is inclusive, which is a little bit confusing, but you will get the hang of it. All right, there's also some built-in functions for strings. There's quite a few of them, actually, for converting uppercase and lowercase and stripping off extra spaces and new lines and stuff at the end of the string. There's a ton of these built-in strings. But just to keep things simple, I'm just going to mention one here, len. And so len actually is going to count the number of characters in the string name and return that number. So len is always going to produce a non-negative value. Even if I pass it an empty string, then len will return 0 characters. Okay, now I think we've talked about this before, but I want to mention it again. If you have the plus operator in 2 integers or 2 floats, it's going to do arithmetic addition. But with strings, it concatenates them. So we usually, in many programming languages, we use the same operator for a couple different purposes. In this case, when we have 2 strings, it concatenates those strings together. So here I've got a string name 1 that has Carla. I've got another string name 2 that has Rodriguez. And then when I add them together, here I'm printing the result, but that doesn't really matter. Here I take name 1 plus name 2. It's going to concatenate them both together. And the result of this expression here is going to be Carla Rodriguez. Now, there aren't any spaces in either of these strings, so it's not going to put a space in between automatically. So if you want a space in between these 2 names, you'll have to manually put a space in between them by concatenating a 3rd string in the middle. Okay, now one important thing here is Python will not allow you to concatenate a string to an integer. So for example, I might want to, if I know somebody's name, I might suggest a username for them. So maybe I want to suggest that Carla's name username should be Carla05. And so what I might do is I might have the number 5 and Carla, and I try to add them together. It's not going to allow me to do that because you can't add a string to an integer. It's just not a compatible combination in Python. But if you do want to do that, what you can do is you convert the 5 to a string. So you can use the str function to convert the 5 to a string and then concatenate it to Carla, and then you will be able to create your username. You can also multiply a string times an integer. So remember that there's certain types where these combinations work. So adding 2 strings together works. Adding a string to an integer doesn't work. Similarly here, I can multiply a string times an integer. That works. But I can't multiply a string times a floating point, and I can't multiply a string times a string. And we're going to see why that is, because those concepts don't really make sense. this combination does make sense, and we can reason our way through that, because if you think about it, when you multiply something by 5, let's say I'm multiplying some value by 5, like str, that really just means str plus str plus str plus str plus str. 5 strs added together, right? And we know that if we add two strings together, if we were to say str plus str, it's going to concatenate that string together. So str times 5 is equivalent to concatenating string str 5 times. And that's exactly what it does. So here's some examples. Here I have a string that just contains a single dash, and I'm multiplying that by 10 here. That's going to create a new string that is 10 dashes. And you can also put the integer first, although customarily we usually put it at the end. And by the way, for just a couple points, you can multiply a string that has more than just one character in it. That's perfectly allowable. So in this case, this ABC is being multiplied by 8, so it's going to be ABC, 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 ABC 8 times. And by the way, the n here is a variable. Sorry, I made a typo here. It's supposed to be num. It's supposed to match this number. It's a variable. You don't have to hard code the value. You don't have to actually say 8 like I'm doing here, times 5 or times 10. These values, I've hard coded the value. This can be a variable that maybe it actually has more than one value. So for example, maybe num is sometimes equal to 5 and sometimes it's equal to 8. And I multiply times num. That might make a string that has 5 ABCs, or it might make a string that has 8 ABCs. So that's also possible, which does come in handy sometimes. Okay, so we've learned about for loops in the past, but just to quickly remind you that you can loop over a string, and what that does is it loops over each individual character in the string. So I've kind of used my variables here to help me remember what this program is doing. So that's a custom that I follow. I usually make sure that my program is as readable as possible. One of the best ways that you can do that is choose your variable names wisely. A lot of times your coding environment will automatically complete the variable name. So if your variable name is a little bit long, it honestly doesn't matter that much because you have autocomplete. And so you don't have to type the whole thing out. You can just accept the autocompletion by hitting enter or hitting tab or whatever. And so making it a little bit longer might make your program more readable. And as a result, you don't need as many comments. So that's a little controversial because the first semester programming instructor isn't supposed to say comment less. I'm not saying comment less. I'm just saying, first and foremost, make sure your program is inherently readable. And for any parts that are still a little challenging to understand, then you can add comments to help somebody reading it. Mainly you. Really, we're talking about helping you, because you're going to go back and look at your code. You want to be able to remember what that does. So if we do an example in the class, like our next lecture, we're going to do some demos, and you go back and look at it later when you're trying to complete a lab assignment that has related requirements. You want to be able to understand what your program is doing. So that's one way that you can do it, is try to make sure that you choose appropriate variable names that'll add to the readability of the program. And if that's not enough, then you can add comments to fill in the gaps. All right, so just keep in mind there is the range function, and I believe we've talked about the range function before. The range function actually generates a sequence of values, and we can pass 1, 2, or 3 arguments to range. And it allows us to generate different sequences with a different starting number, a different ending number, and a different step size, very similar to the step slices that we saw in an earlier slide today. This code is doing the exact same thing as the code on the previous slide. So this code right here, this code is a lot more readable, but sometimes you want to go over the characters of a string, but you need to know where they are in the string. So this one doesn't help you with that. It just tells you what the value is. It tells you the letter in the name. It doesn't say what index in the string is that letter. So if you actually want to know the index of it, then you might need to use something like this. So this is actually common if, for example, imagine you're comparing two strings at the same time, and you want to compare the third character of each string. If they are different, then you want to know which index so that you can access the third character of the first string and the third character of the second string. And you can also, maybe if they're not the same, you can print out a message that says, the characters that in column 3 aren't the same. So that's what this program does. Now I'm not actually using the index for anything, but I'm just showing you how you could loop over them. So in this case, we have len of name. This is kind of confusing because we say for I in range of len of name. We're kind of calling two functions there. Just keep in mind, it goes from the inside out. All right, so first, it's going to call the len of name, and that's going to count the number of characters in Carla Rodriguez. And how many is that? It's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, counting with Randy. So that's going to produce 15. And then the 15 is going to become the argument to the range function, which, if you remember from our discussion of range previously, range actually, if you just pass a single argument to it, that's the end index. So it's going to produce all the values between 0 and that end index exclusive. So including 0, but not including the end index. So this is going to produce I values from 0 all the way up to 14 because there are 15 characters in the string. Okay? And because I doesn't contain the letter or the character of the string, it contains the index within the string. In order to print that character, just like we did in the previous example, instead of printing letter, I print name square bracket I, which gives me the value of the character at index I. Okay? And I is short for index. By the way, I usually use I for that purpose. And if I is not readable enough, you can use the word index if you want. All right, so now let's talk about lists. What we're first going to find out is that a lot of things about lists are actually the same. Okay, so a lot of things that we just learned about strings can also be used for lists. Although lists are a little bit different because they are immutable types. What it means is if you have a list, you can change the list. You can add things to the list. You can remove things from the list. With strings, you can't exactly do that. What you can really do is make it a duplicate copy of the string with some changes being made. But the string in place doesn't generally change. But the list, you can create a list and then make changes to it. We're not making a whole new list. We're just sort of modifying the existing list. Okay, so first let's talk about indexing like we did with the string. It basically works the same way. So with a list, I can have a list of values. Just one thing to keep in mind throughout this whole part is that lists can be of any type. So this is a list of integers, but it could be a list of floats. It could be a list of strings. We're going to see later that it can be a list of a lot of other kinds of types as well. So you can have lists of lists. You can have lists of tuples, lists of strings, whatever. All right, so here we have a list of integers. And I can use 0 or positive indexes to start counting the values, and it'll give me the element at index 3, which is counting from the left-hand side. So 0, 1, 2, 3. Okay, so this is the value that's going to get printed out. And then we can also use negative indexing if we want to start counting from the right-hand side. So just like with strings, -1 is this one, -2, -3, and so on. So this last line here is going to print the 9 because it's in the last position. That's index -1. Now just keep in mind, this 9 is also at index 9. Right, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Counting from the left-hand side, this is index 9. And counting from the right-hand side, it's index -1. And similarly, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10 also points to the 0 value. So we could say num's at -10, and that'll also output 0. Obviously, it kind of makes sense that the value is closer to the beginning to use the positive index, and if it's closer to the end to use the negative index. But just so you know, you can use either one. Every value in this list has 2 indexes that are possible. Right? In most programming languages, you can only use the 0 or the positive indexes. So it's generally a good idea to use that, except in certain cases. For example, num's at -1 always gives you the last element, which is kind of inconvenient to do using the other kind of index. So negative index is preferred in that case. So pretty handy. All right, so how do you insert values into a list? Well, the easiest way to insert is to use the append function. So you can see here the append function just takes one argument, it's a new value, and it automatically adds at the end of the list. Okay, in fact, you can use it in other types of sequences. But here we've got a list 0, 2, 4, 6, 8. Append automatically adds to the end, so the resulting list after this line of code here, ignoring these, pretend these don't happen here, nums.append is going to add the 10 to the end. So we might have 0, 2, 4, 6, 8, 10. Okay, but we will also have inserted another value right here. So let's go through that first. Let's go through that next. The insert function allows you to insert at any position. So it's a little bit more complicated to use the insert function. Append always adds to the end. but sometimes you don't want the value to be added at the end. So for instance, these values are all in numerical order, and say I want them to stay that way. What I might do is I might try to insert the 7 into the correct spot. So I'm trying to insert a 7 here, so I can use the insert function in order to do that. All I have to do is figure out where should I insert it. What index should be used for the 7? Well, let's figure it out. I want the 7 to be right here, right? So index 0, 1, 2, 3, 4. Index 4 is right here where the 8 is. Well, if I insert the 7 there, the 8 will be pushed to the next spot. So it'll be 6, 7, 8. So inserting at index 4, the value 7, we'll actually insert the 7 in the proper numerical order. And then we add a 10, which goes at the end, so that also makes sense. If I want to insert at the beginning of the list, so if, say, for example, I want to insert -1, then what I would do is I would say nums.insert 0, index 0, -1. So that would put the -1 before the 0, and all these values are shifted over by one index. All right, so that's actually really handy. We use append all the time because it's so convenient. We don't need to figure out what position to insert, but you will use insert in very specific scenarios. An example that I've been giving is if you want to keep a list in some kind of order, then you might use insert. But otherwise, if you don't care the order of the values, then you can just use append, which is the case most of the time. All right, next we'll talk about how to delete. Well, one easy way to delete a value is literally just say .remove and then that value. So if this was a list of strings, just keep in mind I would say nums.remove, Fred or whatever, and it would remove Fred from the list of strings. In this case, I'm saying remove 4. The reason why I'm giving you that distinction is because 4 could very well be an index, because integers, of course, are used for indexes. But in this case, the 4 that I'm specifying here is the value. I want to remove the 4, not the value at index 4, but the actual 4. So in this case, 0, 1, 2, 3, 4, the 8 is the value at index 4, but this remove is not going to remove the 8. It's going to remove the number 4. Okay? So you might actually want to remove a value at a specific index, so I'm going to show you how to do that as well. With the remove function, one thing to do is to remember that it removes the value. All right, there is a pop function as well, kind of like the append function, does kind of the opposite of what the append function does. Append adds a new value to the right-hand side of the list. We call that the end of the list. And the pop function removes the value at the end of the list. So in this case, we have numbers 0, 2, 4, 6, 8. If I call nums.pop, it's going to remove the 8 because it's at the end of the list. Okay, so it always removes the last element. However, it is possible to pass an index to pop. So just this is the simple one, like kind of the opposite of what append does, but you can also call pop with an index, and that's the opposite of the insert function, where I'm removing a specific value at a specific index. So in this case here, we've got 0, 2, 4, 6, 8, and I say pop with an argument of 1. That's saying remove the value at index 1. And index 1 is this 2 here, so it's going to remove this 2. So sometimes students get a little bit confused and they mix up the remove function and the pop function because they both take a single argument. Remove takes a value, and so if you had a list of strings, remove would take a string argument, but pop would still take an integer argument because pop specifies the index of the value that you want to delete. Remove specifies the value that you want to delete. Okay. In list, you can also have slices, and so you can use slices. They basically work exactly the same way as they do with strings, but just because slices is a relatively new concept, let's actually go through a few examples. So here I've got a list of numbers, the numbers from 1 to 10. So nums 3:6 is going to say, well, I want the numbers from index 3 up to but not including the numbers at index 6. Okay, so these indexes are 0, 1, 2, 3. So 3 is this 4, so 4 will be part of the result. And a slice is going to return a list. When you're talking about a slice of a list is also a list. So from 3 to 6, not including 6, is going to include the 4, that's index 3, the 5, that's at index 4, and the 6, that's at index 5. But not the 7, that's at index 6. Remember that 6 doesn't get included, it's exclusive of index 6. Okay, so it'll just return the list with 4, 5, and 6 in it. Now this one here, again, the start index is assumed to be 0, so this is going to give us all the values from index 0 to 4 exclusive of 4. Okay, so that's going to give us 0, 1, 2, 3. So we're going to include 1, 2, 3, 4, but not index 4. That's the 5. The 5 doesn't get included. So 0, 1, 2, 3, sorry, 1, 2, 3, 4 will be included in this case. And then if I say 5 colon, I leave out the end index, it assumes that the end index is going to be the length of the list. So in other words, go all the way to the end of the list. So starting at index 5. Index 5 is the 6, all the way to the end of the list. So it's going to produce 6, 7, 8, 9, 10. Keep in mind, 10 does get included when you don't specify an end index. Okay. And you can also have step slices. So just like with strings, but let's go through an example just to get a bit more practice. So from 2 to 8, including 2, but not including 8, with a step size of 2. So 0, 1, 2, so 3 gets included. Then we go up by 2, so we go to index 4. So 5 gets included because 4 is still less than 8. And then we jump up by 2 to index 6. 6 is less than 8, so we also include the 7. So 3, 5, 7. And then we jump up by 2 again. That takes us to index 8, but 8 doesn't get included. So it's literally just 3, 5, and 7. So it'll produce a list with 3, 5, and 7. Let's do one more. So index 1. Index 1 is the 2, but we're going to take a step size of 3 going up to index 10. So we're going to say 2 first of all, and we're going to go up 3 more to index 4. So index 4 is this 5. And then we're going to go up 3 more to index 7. Index 7 is this 8. Okay, so we're going to include the 1, the 4, the 1, the 5, the 8. Sorry, the 2, the 5, and the 8. I forgot already, sorry about that. So let me try this again. From index 1 to index 4 to index 7. And then adding 3 more to the index brings us to index 10, but 10 doesn't get included. And it's also a good thing because there isn't any value at index 10. This is index 9. So anyway. So please note that these 3 values in the slice operator work the same way as the 3 arguments to range. So with range, we have the start index, the end index, and the step. And the start index is inclusive. The end index is exclusive. And you can also leave out most of the values just like you can with range. So it works the same way. And as I was saying before, it's consistent in Python. It just takes a little bit of getting used to. All right, so some functions that operate on lists. Of course, we've got the len function that we talked about before. So down here, we've got the len function when applied to nums. It's actually going to count how many nums. So this one's got 10 numbers in it, so it's going to return 10. There's also a max function that'll return the maximum, and a min function that'll return the minimum. And I know this is in ascending order here, but max and min can find the maximum minimum value even if they're out of order. Okay, so it doesn't automatically return the last element or the first element. It actually searches through all the values and finds the biggest one or the smallest one. There's also a sum function, and there is quite a bit more, but just for a couple of examples, you can calculate the max and the min and the sum. So just a quick comment, if you're first learning how to program, these 4 functions here are a really good way for you to start and to practice with your programming because they're very basic. Now, eventually, I want to get to the point where you're just going to use the built-in functions. If you want to know how many elements are in nums, just use the len function. If you want to sum up a list of numbers, use the sum function. I wouldn't expect you to use to build your own function to do this. But actually, while you're learning, it is a very good idea for you to practice because these are relatively simple problems to solve. Now, there are built-in functions, so you wouldn't normally use them. But I think if you skip over writing these functions yourself, then you're just denying yourself a relatively simple challenge, which helps build your foundational knowledge, helps you become a better programmer later. Long term, of course, you're not going to reinvent the wheel and write your own functions. But in the meantime, you've learned something and you've become a more competent programmer. So I strongly recommend that you try, as like a homework exercise, try to implement the code for these. Now, we don't know how to write functions yet, but just basically, create a variable like nums here, and then just write a loop to go through and count the number of elements in that list, or find out the maximum, or find out the minimum, or calculate the sum. And then you can figure out how to put them in functions a little later. All right, some other functions. We talked about the range function. And so, sorry about the formatting here. So range with just one argument actually produces the values from 0 up to, but not including that argument. So in this case, 10 is going to produce the values 0 through 9. If we do pass the start index, then it starts at 2 and goes up to, but not including the end number. So in this case, starts at 2 and ends at 10, but doesn't include 10. So 2 through 9. And then 2, 10, 2 will include a step size of 2. So we're going to go 2, 4, 6, 8. And it doesn't include 10 because that's the end number. So it's exclusive. So for example, if I wanted to go through all the numbers, I wanted to print all the numbers from 0 through 9, I could write the code like this, but this is really awkward because I had to write 10 numbers out by hand. I could use the range function for that. And in fact, even the 0 here is optional, but this code is a lot more compact. And if I wanted to print all the numbers from, from 0 to 1,000,000, or if I wanted to print out every 7th number from 0 to 1,000,000, clearly using the range function is going to be the preferred way to do this. Okay. Sometimes with a list, you want to test membership. You want to test to see if a value is in the list. And so, for example, there is a keyword in, which works as a Boolean operator. So the left operand for the in keyword is an element. It could be an element of any type. And then the right is some kind of a sequence. So in this case, it's a list. And it's just going to return true if 3, the element on the left, is in the sequence on the right. In other words, in this case, is the 3 in the list 1, 2, 3, 4, 5. That should return true because 1, 2, 3, 4, 5 does have a 3. There's also an operator not in. I know it's two different words, but it's a single operator. And it's going to return the opposite of what the in does. So in this case, 3 not in 1, 2, 3, 4, 5 is going to return false because there is in fact a 3 in 1, 2, 3, 4, 5. So this is actually pretty handy. So down here we've got an example program. So we've got a list of numbers 1 through 10, and I'm just checking if 3 in num. So I'm using an if statement here. Remember that the if statement has a conditional. That's a Boolean value, and the in operator is a Boolean operator, and so it produces a Boolean value. In this case, it produces the value true because 3 is in nums. Here it is right here. So it does exist in there, and it'll still return true, by the way, if there's more than one 3 in the list, but this will return true. And so it will print out this found 3 message here. This is super helpful. We're going to see how this is a very important thing to know how to do because a lot of times you might operate on the assumption that the value is in the list, but it's actually a lot better for you to just make sure. Don't assume that something is in the list because you think it always should. Check to make sure that it is. Even if it takes a few compute cycles in order to do that, it's better because your program will handle a little bit more gracefully the situation. That should never come up anyway when it isn't in there and you expected it to be. All right, so here's some more ways to test for membership. We can actually find out where the index of the value is. So for example, here I take a list. You can put the list in a variable first if you want to, but here I just literally take the list and then I say .index 3. All I'm asking here is, at what index is the 3 in this list? And it's at index 0, 1, 2. So the result here is going to be 2 because the 3 is at index 2. But here you have to be very careful because I'm assuming that this 3 is in the list. And if I happen to know it's in the list, that's fine. But if I don't, then I'm taking a chance. Because look what happens here if I have 1, 2, 3, 4, 5.index 8. There is no 8 in this list. So it doesn't know what to return. Python doesn't know what to return. In a lot of other programming languages, this index function will return a -1, indicating like a special number that says that's not in the list at all. But Python's index function can't do that because -1 is actually a valid index. So for example, if I said 1, 2, 3, 4, 5.index 8 and it returned -1, I might then say, okay, well, give me the value at that index, -1, which would give me a 5, which is kind of surprising. I'm saying, where's the 8? The 8's at that index? Okay, what's at that index? It should be an 8, but actually it's a 5. So that's weird. And so Python tries to avoid that by giving you a runtime exception. So it's specifically a runtime exception. It'll tell you specifically on what line it happened and so on. But generally speaking, because when Python encounters an error, it quits your program, it's really much better for you to write more safe code. Okay, so in this case, this will crash your program and it won't continue, rather than handle it nice and gracefully and just output a message saying there is no 8 in that list, for example. So that's why you can use this in combination with the in operator. You could say if 8 in 1, 2, 3, 4, 5, then find the index 1, 2, 3, 4, 5 dot index 8. So that won't crash because the if statement will mean that it only actually calls the index function if the 8 is in there. Another way to do it is you can also count the number of times the 3 occurs. So in this case, for instance, there's 3 3s in this list, so this is going to return 3. But if I were to do something like take this list dot count 8, there are no 8s in here, but it doesn't crash. It just produces a value of 0. It counted 0 8s. So that's another way of doing it. You could count how many 8s there are, and then if there's not 0 of them, then you could find out the index of them. And this, by the way, I'll give you the first index of the first 8 in the list. This would be the first index of the 3. There is also, by the way, another function, rIndex, which will start counting from the right-hand side instead of the left-hand side, like the index does. Anyway. So down here, nums.index3 is going to actually search for the index and therefore produce the index of the 3, which is going to be 2. So this is going to print 2 because that's index 0, 1, 2. This one's going to crash. That's why I have a little comment sign here so that I don't run this program. Because if I try to find the index of the 20, it's going to crash because there's no 20 anywhere in the list. I can also count the number of 3s that are in there, which in this case, there's just 1 3. So this is going to produce an output of 1. All right. So just like we can concatenate 2 strings together, we can also concatenate 2 lists together, and it basically works in a very similar way. So if I have 2 lists, if for example, I have the list 1, 2, 3, 4, 5, and I also have another list 6, 7, 8, 9, 10, and I concatenate them together using the plus operator, then they both have to be the same type, they both have to be lists, it's going to create a single combined list with 1, 2, 3, 4, 5, and also 6, 7, 8, 9, 10. So it's going to have a 10-element list as a result. So you can join 2 lists together really easily. We still call this concatenation, just like we did with strings. And you can also use the multiply operator. Obviously, if you can add 2 lists together, then you can multiply a list times an integer, because basically that list is just going to be repeated. So for example, here in this case, I have a list 1, 2, 3. I'm multiplying it times 10. Well, that's the same thing as 1, 2, 3 plus 1, 2, 3 plus 1, 2, 3 10 times. So the resulting list will be 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 10 times. A single list that has 30 elements in it. Okay, and here we go. We got the variable n here. And again, n can be set to different values depending on how the program is run. And here I've got a list of strings just to kind of remind you that so far we've only been using lists of integers. Lists can be of any type. So in this case, this is a list with 2 strings in it. And this is going to multiply that list of strings 8 times, which means I'm going to have the list that has Bob, then Smith, then Bob, then Smith, then Bob, then Smith, basically repeated 8 times. And that could be handy potentially. With for loops with a list, of course, you know that this is one of the main reasons that we use a for loop is to iterate over a list. So of course, you can iterate over the elements of a list, and you know how it works. It's going to take the 1 out of this list and put it into element, execute the body of the loop. Then it's going to take the 2 from the list and put it into the element variable and execute the body of the loop with element being equal to 2, and so on for all 5 of the values in this list. So that's how a for loop works. But of course, we sometimes also want to use the index. Again, we want to know where in the list is it, just like we wanted to know where the character in the string was. So same kind of deal here. So we can also use the range function. So this one's going to go through a list of numbers. This is just a more compact way of representing this, except this one goes all the way to 10. And this one down here actually goes through the values, the indexes rather, of this list. So in this case, list can be anything. It happens to have 7 values. So in this case, len of list is going to return 7. So we're going to call range with an argument of 7, which is going to produce the values 0, 1, 2, 3, 4, 5, 6. And that's perfect because the indexes of this list are 0, 1, 2, 3, 4, 5, 6. And you notice that that comes from the fact that range is exclusive on its end index, right? Because when you call range, This is like calling range with 0 as the start index. It's sort of implicit because that's the default value. All the way up to len of list, exclusive. It's exclusive because if we went all the way to 7, then we would go from 0 to 7 inclusive. And there isn't a valid index 7 in this list right here, right? 0, 1, 2, 3, 4, 5, 6. Index 7 is empty. And so there is no valid value here. So the fact that range is exclusive on its end index is closely related to the fact that we usually use zero-based indexing. And as a result, there isn't a value at the index equal to the length of a list or a string or whatever. Okay, anyway. So as we were talking about, lists can be of different types. We saw a list of strings and we saw plenty of lists of numbers. But we can have a list of characters or a list of Boolean values if we wanted to. We can have a list of tuples or dictionaries, which are types we haven't talked about yet. We're going to talk about next. And we can also have a list of lists if we want to. So a list of lists is called a 2D list or a matrix. And so let's just look at that as an example. So first, let's build a type using like separate lists. So let's just build some normal lists. So list 1 is set to a simple list of 4 integers here. List 2 is another like non-two-dimensional list, just a one-dimensional list. It's set to another list of 4 integers. And list 3 is set to a different list of 4 integers. And then I create a matrix by having a list that consists of those 3 lists. So you can see that I'm using square brackets, I'm using commas in between. It's just that the values of this list are themselves lists, okay, which is why we call them lists of lists. It's a list whose elements are lists. And in fact, you could have a list of lists of lists. That would be a 3D list. That would be possible as well. They get a little hard to visualize, but it is possible to go as deep as you want with lists of lists of lists of lists of lists if you want to, okay? So for machine learning people, this might be relevant, or holographic programming. Anyway, so this example here just kind of skips the steps. So we have like 4 lines just to create this one list of lists. This one just skips all of those other intermediate variables, and it just literally creates a square bracket, commas in between, and then it just like hard codes the list here. So that's possible too. And by the way, if you want this to be a bit more readable, what you can do is you can kind of hit enter right here and indent this first list, and then after the comma you can hit enter and indent the list, and then you can, after this comma, you can hit enter and indent the list, and then all the numbers of the list will line up. If that is good for you, and I usually do that in my own program, then I encourage you to do that. Again, that adds to the readability of the program, which can be a really good thing. If it matters that the columns of the numbers match up. All right, so what's kind of confusing about this is how do you get the individual values of a matrix or of a list of lists? Well, that's what this last example is all about here. So we've got matrix 2. Matrix 2 is a list of lists, right? So the first square bracket here makes perfect sense. It's saying, give me the first element of matrix 2. The second element of matrix 2, because index 1 is the second. And so this is index 1. This whole list is at index 1 of matrix 2. This whole list, index 0. I got a little confused there, sorry. Remember, on Python, all of your indexes are 0-based. And so this is the first index of matrix 2, index 0. Index 1, which is the one that we're requesting, is this entire list. Okay, so if I just say matrix 2 square bracket 1, it gives me this whole list 4, 5, 6. But if I say square bracket 1 and then square bracket 2, this square bracket applies to the list that matrix 2 square bracket 1 produces. So matrix 2 square bracket 1 produces the list 4, 5, 6. So matrix 2 square bracket 1 square bracket 2 gives me the third element of that list. 0, 1, 2. That's this value right here. Okay, so we can arbitrarily get any value inside our list of lists. So for example, imagine I want to get this 7. Okay, so to get the 7, what I would say is matrix 2 square bracket 2, because of the list, this is list 0, this is list 1, this is list 2, and the 7's in list 2. So I say matrix 2 square bracket 2, and then 7 within that list, 7 is at index 0. So then I would say square bracket 0 for the 7. Okay, so you can actually get any value. At first, you might mix up these two values, but just try to work it out in your head. The first bracket is going to first limit which list within the list are we grabbing, and then the second square bracket is going to say which value within that list. So it makes it easier if you reasoned it out that way. All right. So in summary, a list is usually a collection of the same kind of value. So as an example, maybe you're making some code for Amazon, and therefore your list is a bunch of the same kinds of things. Like maybe they're the prices, or maybe they're the orders that you've taken. Every single element of the list is an order. Every single element of the list is a price. They're all the same type. So normally lists all have the same type. So you've seen when I've had an example of an integer list. Here's an example of an integer list. They're all integers in here. And here, same thing. Each one of these is a list of integer. So this list, matrix 2, is a list of the consistent type of a list of integers. It's a list of integers. And so that's consistent. I don't think that you have to make sure that that's true. I think you can combine different values together and kind of mix and match, but it's really not recommended. So what you should normally do is keep your list consistent. So if you have a list of strings, make sure that all the elements in that list are all strings. Be consistent about it, because what you might do is you do a for loop, and then you go through that list of strings, and then you're going to try to do some string operations on that. And if some of the values in there aren't strings, then those string operations could fail or do something unexpected. So it's a good idea to be consistent. That's the purpose of lists. It's for multiple values of all the same type. So to give you an example from my life, I do a lot of marking. And so it would be reasonable for me to use a list to represent all of the midterm grades, for instance. If I had just finished marking some midterms and I was ready to post them, then what I could do is a list. I could have a list of, say, floating point values, which are the student scores for that midterm. They're all the same kind of value, so a list is appropriate. All right. So let's contrast that with tuples now. So when I was learning computer science, my professor said, and I don't know if this is true or not, I believe him, I guess, so I better take his word for it. Tuples comes from the fact that there were two values in it. So it's like a pair of values. That's not the case with Python. With tuples, you can have 2 values, 3 values, 4 values, 33 values, 108 values, whatever. You can have any number of values in your tuple. But tuples do not have to be the same type of value. So you can kind of imagine that where I'm talking about, midterm scores, like on a spreadsheet, that might be the columns of the spreadsheet. The tuple usually would represent the row. So we're talking more of a horizontal slice of data. And the row in my spreadsheet might have the student first name, the student last name, the student ID, the midterm scores, the assignment scores, the final exam scores, and so on. And those are different types of values. Some of them are strings, some of them are numeric. They're different, right? And so tuples can have different types. So we typically use tuples for collecting different kinds of values, all related to the same concept. So let's look at a few examples. So here are a few examples of tuples. So the first one is a customer. We've got 3 values. I don't know what this represents. So maybe I have a business and I have a customer named Chad Witherspoon. And Chad's been a customer since 2013, December 9th. And maybe he's got a balance owing of $408.51. I don't know. I'm just attaching meaning to these values that don't necessarily have to be specifically what they mean. But anyway, that's an example of how this could be used. Notice that the syntax that I use for these is I just put a comma in between, just like I do with the list. But unlike a list, I don't put the square brackets around it. So if you put square brackets around it, then it's not a tuple, it's a list. If you don't put square brackets around it, then it's a tuple. But again, as I said, conceptually, tuples and lists are used for different purposes. Lists are used for multiple values of the same sort. So I might have a list of all the balances owed of all of my customers. But this one is a horizontal slice that's kind of showing me all the information about this Chad Witherspoon person. Okay? And those values can all be different types. Again, back to the Amazon, I might have a product. So I might have, product ID, I might have a description, I might have a price, I might have a category, all kinds of things about the product. And those wouldn't necessarily be the same type. So in this case, we've got a string, which is presumably the name of the item, and the price, presumably. Or we can have a trial. Let's say I'm going out into a field experiment, and I'm taking a bunch of samples. And I'm ready to take sample 3000 and enter it into my data collection device, maybe my phone or whatever. And I take a sample, I measure how much, like maybe I'm collecting water samples. I measure how much water, and then maybe 13 and 50 are parts per million for certain contaminants that I'm measuring for. Okay, so I can add these. And these aren't the same type. They're integers and floats kind of mixed together. I should generally keep it consistent so that the first element is always an integer. It represents the trial number. And the second one is supposed to be a floating point, that kind of thing. They can be the same type. So here's an example where actually both of the values in the tuple are integers. And this is actually kind of a shortcut that a lot of Python programmers sometimes use, is they will actually do multiple assignments. So this is basically an assignment statement that's setting two values simultaneously. So all of these are taking the tuples and putting them into a single variable. So the customer variable here contains Chad Witherspoon, and it contains 2013-1209, and it also contains 408-51. Those are its different components, and you can use the square bracket notation, in fact, to get the individual components out of there. So customer square bracket 0 will give Chad Witherspoon, for example. But with XY, instead of just putting a single variable on the left-hand side of the assignment statement, I put two of them there. And that actually allows me to set x equal to 0 and y equal to 5. And this allows you to break up a tuple into its individual components. So for example, instead of setting customer equal to this, I could do something like name, comma, date, comma, balance equals this. And then it'll put Chad Witherspoon into the name variable. It'll put 2013-1209 into the date variable, and it'll put 408-51 into the balance variable. So that's actually a really convenient thing that you can do in Python that it doesn't really exist in other programming languages, unfortunately. So it actually makes your code a lot simpler to write. If, however, that's just overly complicating things, you can literally write out x equals 0 and then on a new line write y equals 5. That'll have the same effect as this one line of code here. If you want to set multiple values in the same line, then feel free to use this. So as I was saying, tuples are actually really useful for creating these horizontal slices of data. So that's different pieces of data about the same concept. So maybe information about a student or information about a product or a customer. A dictionary is used for the exact same purpose. So you may wonder, why does Python have both tuples and dictionaries? And as you just saw, tuples are very compact. We literally just put values with commas in between. And so it's a very efficient way for a programmer to use. But the dictionary actually creates more readable code. It sort of makes a lot less bugs and so on. So dictionaries can be used in the same context. I believe the dictionaries were added at a later time. Tuples were kind of there since the beginning of Python, and dictionaries were added a bit later. And also tuples are something that, they exist in Python and a few other languages, but they don't exist in all programming languages. However, dictionaries are something that are kind of indispensable. Most programming languages have dictionaries. So I think just to be sort of consistent with other programming languages, that Python added dictionaries. And I'm really glad that they did, because there is a great advantage to using dictionaries that allows things to be a little bit more common sense when you're working with your program, which is probably going to lead to fewer bugs. So this is the same customer, basically, that we had in a tuple a couple slides back, but I'm representing it as a dictionary here. So we still have Chad Witherspoon, 2013-1209, and 408-51, same three values, but now we're actually attaching those values to corresponding strings here. So all of these things on the left are the associated, we call them the key. These are the keys. So this customer has three keys: name, join date, and balance. And each of these keys has a corresponding value. So name's corresponding value is Chad Witherspoon. Join date's corresponding value is this date, 2013-1209. And balance's corresponding value is 408-51. And you can see that each of these pairs is separated with a comma. And we put a colon in between the key and the value. Okay, the values are still the same. So we're still representing the same data, and it is a lot more to type, actually. With autocomplete, it's not generally that bad, but it is a lot more to type. So dictionary is definitely more typing involved. But the big advantage of it, I was mentioning before, if you wanted to get Chad Witherspoon in the tuple, what you would do is you would say customer square bracket 0. you would remember that the name was the first field in that tuple. And so you would say square bracket 0. Remember, 0 gives you the first value, just like with a list. But with a dictionary is kind of a powerful alternative to a list. It allows you to reference things instead of by their index. You can use their key, which is a string, in fact. So it makes it a lot more readable. When I want to grab the name of this customer, what I'll do is I'll say customer, square bracket, and then in quotes, name. Okay, so that'll actually say, give me the name field of the customer. And then if I want to get the balance, I'll say customer, square bracket, and then in quotes, balance. That'll give me 408.51. This is really convenient because I might accidentally put these values in the wrong order. In a tuple, that would be a disaster because I'd end up getting the wrong value and using it in the wrong way in my program. But in a dictionary, if I'm using square bracket balance, that's always going to give me the balance. Even if I accidentally put the balance first in the dictionary, it doesn't really matter. It's also the case that generally dictionaries are a bit more efficient for getting your data. I don't know if you'll necessarily notice that difference, but it is possible to implement a dictionary very efficiently using hash tables, and that's something that we'll address a little bit later in this class. Okay, so that's an alternative to how you can use dictionaries. And I think what I'm going to do is for all 4 of these types in the demo session, I'm going to produce a lot of examples so you can get a lot of practice with it. Again, lots of practice is a very good thing. So try out some of these examples for now, and then in the demo session, we'll do some hands-on examples. All right, so that's all for now. So in the next one, we're going to be covering functions, which could be useful. You can finish writing the len function and so on. That can be really helpful, but this is actually most of the useful code that you need to know. Functions are pretty handy for making things nice and neat and clean, but you don't really need them in order to write your program. It can just make your code a lot more readable and less duplicated. But we're learning kind of the most important stuff. We've learned already the most important stuff up until now. So next time we're going to learn functions, which I'd say are probably the next most important thing to learn in programming. All right, so see you next time.